Hello and welcome to another video. In this one we're going to be working on convert 1D array into 2D array. And in this problem you're given a 0 index 1-dimensional array, original, and 2 integers m and n. And you're asked with creating a 2D array m by n using all the elements in original, and the elements from the first 0 to n minus 1 should form the first row, the elements from this should form the second row, and so on. So we'll briefly describe what that means and so on. So return an m by n 2D array constructed according to the following procedure. But the basic idea is we're given a m by n, and we can just make a 2D array m by n, and then we just put in the elements in the same order as they were here, row by row. So we'll put in the elements this way, so we'll put them in like that. So this will be, if we index them, this will be like 0, 1, 2, 3, and then this is the order we're going to put them. So you just go row by row and you fill out the row, and we're asked, is that possible? So in this case, it is possible, and you would get this. In the second example, you're basically asked to make another 1 by 3, so that's possible as well. So you just make a 1 by 3. And here, this is an array of length 2, and you're asked to make a 1 by 1. So 1 by 1 only has one item, and we have 2, so we can't do it. So first of all, what's the criteria to know that we can't do it? Well, an array that's m by n has m by n elements. So m by n has to equal the original length. So we can quickly do that. We can just say, like, let's just take m by n, multiply them together, and they have to equal the original length if their arrays are to match up. And if they're not, then we can just return the empty array. But how do we actually put elements from here into here? So let's just say we have these elements, and they can be whatever, but in this case, let's do this. So in this case, it's really easy because basically we can have an index here. So we can just say like index I equals 0, and then we can do a nested for loop that will traverse our new array. And we can just say like, okay, whenever we're at some cell, let's just put in whatever it's at index I and increment it. So we put in this, we increment it, then we're at this cell, we put in what's at index I, we increment it, we put in what's at index I, we increment it, and we keep doing that until this whole thing gets filled out, right? Because we know like we're going this in order. So just a pretty easy nested for loop that just goes through the rows and then the columns. So you'll go this way, and then you can just say wherever you are, just put in that cell. But I did briefly want to describe, let's say you aren't able to do that. Let's say you're asked, okay, I have this array, and instead of going in order where I can just have index I equals 0 and increment, instead I'm asked like, okay, well, what if I just have some random index I'm at like here? And I'm asked, can I put this in its corresponding cell in this? How would I do that? So basically convert from 1D index into 2D index. And maybe the opposite, right? So if I'm given some index here, how do I convert back? Like, let's say I'm given this index. How do I convert this into a 1D index? So let's briefly talk about that. So you can kind of figure it out, but basically, when you're given a 1D index and you want to figure out the 2D index, you need to figure out the row and the column. And so for the row, you can look at this matrix, right? So every row has, so if this matrix is, let's say this matrix is rows by columns. So every row has columns items, right? Like if there's 3 columns and 3 rows, every row has 3 items. And so to figure out what row we're on, we can just take the 1D index and divide it, floor divide, by the number of items or the number of total columns, right? Because every time we go through all of our total columns, we get through a row, right? Like every time we go through 3 columns, we get to a row. So it's basically, if every row has 3 columns, then to figure out what row we're on, we can just take our index and divide it by that. And then how do we figure out what column we're on? Well, the column is actually the remainder of this thing here. Because like here, if we do, this is index 0, this corresponds to this cell. So 0 divided by 3 gives you 0. And then basically, so the remainders are going to look like 0, 1, 2, 0, 1, 2, 0, 1, 2. So the column we're on is the remainder of 1D index. And that's how you can go from this to this. So this is how you can go from 1D to 2D. Now let's talk about really quickly how you can go the other way. So if we're given a 2D index, how we go from 1D. It's very similar, it's just going to be the reverse. So now we're given a row and a column, so we have to build an original one. Well, every row has columns items. So we can just say, like, give me the row times the columns items, because that's how many items I traversed there, right? And that will give you like how many full rows you traversed. And then you need to figure out what's the extra, and the extra is just the column you're on. So we can quickly demonstrate a couple examples with both of these. So basically, let's say we're given like this thing here. So we're given 1D index 5. So our row will be 5 floor divide by 3, which is 1. So we're on row 1. And then our column will be 5 modded by 3, which is 2. So 5 is going to be this cell. And now let's do the reverse for one example. So let's do this one maybe. So this is row 2 and column 1. And so the 1D index is going to be row times 3, which is 3. Sorry, it's going to be 6. And then plus the column we're in, so that's just column 1, so 6 plus 1, 7. So that would be this. So hopefully that makes sense, and this will be used like for harder problems. Like in our case, we're just going from the start, but if you were to just pick some random cell, this is how you can actually get these things in O of 1. And this is used, like, let's say you're given some, 2D matrix and you're asked to like binary search through it where it's like sorted in increasing order this way. If your numbers are always sorted increasing like this way. So something like that, you could do that without actually like turning it into 1D. You can basically just like get a 1D index given a 2D index and things like that. Okay, so let's use this kind of thing to get a solution now. So the first thing we're going to do is we're just going to say if m by n is not equal to the length of original, we'll just return an empty array. So, because there's no way to do it otherwise. Okay, now let's build our result array. And so the dimensions will be m by n. And now we can loop through our result array, and then we're going to figure out what's the 1D index and put in that number there. And instead of having that I and increment it, we're just going to calculate the 1D index like I showed you. So we're going to say int row equals 0, row is less than m. Same thing for the column. So we're going to say result row column. So we're given a row and a column, and we're asked to calculate the 1D index. And so the way to do that, if we go back, is basically just this right here. Row times the number of columns we have plus the column we're on. So row times the number of columns we have, which is n, plus the column we're on. And yeah, and then we can just return it. And there we go. So this is how you can do it this way, and if you're asked to fill out the 1D array from a 2D array, you would just do the other thing that I showed you. Yeah, so not too much to this one. So this is just, you can think of it as, it's either O of n, where n is the length of original, or m by n. Either one's fine. So I'll just say it's m by n, I guess. And space. We're not using any space because we just make the new array and we fill it out. So we're not using anything else. Yeah, I think that's going to be it for this one. Hopefully it was helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.